Hello guys, welcome to our new video tutorial series about operating system. In previous video I had explained about the process states in Windows and Linux, and in this video I will explain more briefly about the process states in Windows. So first of all, I already explained and I will explain again. Describe the various process states. So we have the new. When a process is being created, the operating system is setting up the necessary data structures to manage the processes. The next one is ready. The process is prepared to run and waiting for CPU time. It has everything it needs to start execution, but it is waiting its turn. Okay. The third state is running state. The process is currently being executed by the CPU. Only one process is one CPU core can be stayed at any given time. Then there is a block waiting. The process cannot continue until external event occurs, like waiting for user input or data from hard disk. Then last state is terminated executed exit state. So in this state, process has finished executing. It can be because it is completed its task, or it can be stopped by the operating system or user. So how actually it occurs, like I will explain the transitions between these states and conditions that trigger these transitions. So first of all, start with new to ready. Once the operating system has set up all the necessary sources of new processes, it's moved to ready state waiting for CPU time. So we have a process states on Windows. As you see that new to ready state is this state where the process is start and created and it's in ready state. Okay, then we have uh, new states. For example, a user created a simple program and it is stored in our secondary memory hard disk. So when its process is created and it's a new state, and now it's going to running state. So for running states, the CPU is available and the process scheduler selects this for execution. So the it will go from ready to running from secondary memory to main memory or RAM. Okay. So for example, just we open a Google Chrome or VMware, and we just open a browser, it will be in a new state. And when the CPU change from scheduler secondary memory to main memory or RAM, it will be in ready to running state. And then we have running to waiting state. So if process need for wait for external event like input output operation, it moves from waiting state. So for now we have created a new state, and then it's ready states. It will create all the structure, the process structure where stack, heap, data, and code, and the process PID, program counter, process state, priority, registers, and all the input output devices. So a CPU just converted from secondary memory to main memory, and the process starts. And when the process starts, it's the CPU created a ready queue, where all the process schedule in these queue. P1, process 1, process 2, process 3, process 4. So this is a ready queue. Like this is managed by the CPU and the scheduler. Okay. Then next state is block waiting to ready states. So when the event the process was waiting for occurs, like the input output operation, it moved back to ready state waiting for CPU time again. So if this is a state like we are in running state and user wants to enter something, so it will not stay in the running state. It will go to the block state because it will require some input output operations, so it cannot be in running state, otherwise it will block the program. It will go in the waiting queue where all the processes are already in the queue, and then once the user uh, input their output operations, it will again go to the running state. Then there's a running to ready. Once the user completed their input output operations, if the process is interrupted, for example, by the operating system scheduler to give another process a turn, like this is a normal process we are running smoothly, but there is some high priority process in our computer, like for hardware processes that needs high priority. So it can be interrupted, and then it will go to the ready state. And once the high process and the CPU starts, processing that high priority process, which is in main memory, and it has already in the queue, and it will give the priority access. Like if there is already one, two, three processes are waiting for that process, but still high priority process will give a high priority. That's why it called high priority process. So after completing the high priority process, it will again go to the scheduler, and scheduler process the next process for the uh, running. So the next step is running to terminate it. So once the high priority, all the processes, complete their running, and all the queue is empty, and all the process has been completed, it will go to the termination state and exit state, and after that exit it will delete it. So this is how the process transitions work in Windows operating system. So I already explained you about all the transitions. So here from the process is created from main memory, from secondary memory to main memory, then it will go to the ready state. It will create a process structure, process control block, ready queue, and then it will go to the main memory, do some input output operations, and then go to the waiting queue, and then again it will move to the running state. And then if there is a interruption from the CPU for high priority access process, it will perform that process, and then again go to the scheduler and ready for the next process. And then after the process executed. So I hope you understand this. So for next video, I will explain about how process states work in Linux. So I hope you understand this video. I try my best to explain you in briefly. So stay tuned with us for next video. Like, share, and subscribe. Thank you.